Then after that, we type a comment that says call subroutine, call this subroutine to accept all the input values. And now we know all of them are legit. Input data. We'll start with the price, options, trade-in, down payment, rate, and term. And remember, all these are by refs. In other words, the changes inside this input data procedure all filter back into the main code. And we know that the price and trading are legit because of all these checks. We know that the options, down payment, rate, and term depend on the check boxes, option buttons or radio buttons, and for the term, for the rate, the list box. So they're all legit as well. They have all the default values and everything's on the up and up. So we will get our good numbers as long as the selling price is reasonable. And so we have to then make the final calculation, intermediate calculation, to calculate amount that needs to be financed as amount equal to price plus options minus trade-in and minus down payment. Okay, save, and then scroll up and down a little bit, up and down this event procedure, the button calculate click, and you'll notice it's fairly small at this point. There's a couple of these check number calls here with the if statements, but other than that, it's the input data subroutine call, a tiny little calculation, monthly payment function call, and then finally the call for the subroutine to display all the results. Okay, so this is the way to break the code, if at all, if at all possible, into small manageable pieces. So what we want to do, we want to emphasize that this is the way the modular design is supposed to work, as is discussed in the last couple of slides, which we'll have in our final video in this series. But before we switch back to the presentation, we want to make sure that we test this extensively. I'm going to do some of it, but it's sort of up to you to try to break it. Okay, try to break the code if it's all possible. If you find an error, figure out a way to fix it. Okay, so we'll start with some nonsense prices, like random text should get us the selling price must be a number. The negative selling price should give us the price must be positive. I don't know, the normal price 12,000. Then let's enter some nonsense for trade-in. It should tell us the trade-in is not a valid number. If we enter negative number for trade-in, it should tell us that it's a negative number. It can be. If you enter 120 grand, that's more than the selling price. You should tell us that the trading value must be less than the sales price. So finally, these two are really the biggest culprits. The only other thing I think of is if we entered trade-in first and don't have the price, it should come up with the selling price must be a number, and please try again, and then you enter something there. There could be a path to this code that I've have sort of failed to foresee, but I doubt it at this point. We'll do the standard 12 grand letter navigation, 5 grand with a down payment until 5 years, and 3.2 just to verify that we get the same result as always. So let's quit, save all the changes, and end this current recording. This and the following slide discuss the basic principles of modular design and structured programming. As you saw from a payment calculator program, modules are small units of code, either functions or subs, designed to handle one or few manageable tasks by breaking up the complex problem into pieces of relatively small size. They should start more general in nature and then break into more specific few layers down, as the car loan breakdown illustrates towards the bottom of this slide. Structured program is characterized by modular design and its use of these three types of basic programming structures discussed at the beginning of the class, namely sequence, decision, and repetition structure. Repetition is the last topic of this class covered in Chapter 6. Advantages of structured programming are many. It is easier to write, debug, and change since you're working on smaller pieces and your teammates are working on other independent pieces at the same time. We illustrated stub programming concept by inserting subroutine heading and end sub, leaving the body blank to be filled out later. Since we coded it all before, all we had to do is copy paste and do some modifications, but in general you would start with the empty functions or subs, determine what they need to do, what, with, and when, and then go and code them one by one top to bottom. Finally, the object-oriented programming uses objects that contain data and methods, kind of like we did with the use of the generic txt box text box object in check numbers function. In addition to pre-built objects like text boxes, the programmers can build user-defined or custom business objects and leverage the true object-oriented design for the most efficient and effective code. This topic is beyond the intro class and will be discussed towards the end of the intermediate programming course, the next one in a sequence, IDSC 3102. In this sixth video, consisting of a series of recordings, we introduce general procedures designed to handle smaller and more manageable tasks. We discussed two types of procedures, functions and subroutines, and finished by discussing the advantages of modular design and structured programming. We used all of these concepts on our enhanced payment calculator application, which ended up with a very concise click event procedure, calling several specialized functions and subs, which resulted in a modular, structured, robust, and efficient code that is hard to mess up and seems to be working quite well. The only other thing I wanted to mention before ending this video is the weekly payroll case study at the end of the chapter 5 in the textbook. That is 5.5 case study weekly payroll, page 210 through 17. So it's a seven-page case study, fairly extensive. It covers everything we've done so far in the class. The only thing it lacks is the repetition structure from next chapter, chapter 6. But it has everything else, and I strongly and highly encourage you to go through it. I'm not going to cover it in the videos, in class, and it's not going to be an in-class project. It's not going to be on the assignment, but you should do it. It's a comprehensive program. It is where all the pieces finally come together. With that, I will end this